So in this video, we're going to look at examples of using the equation of trajectory. So here's a question. A projectile starts at ground level with its initial speed 15 meters per second at an angle of alpha to the horizontal. We've got three parts of the question. We've got a target situated at point 14.4. Find the value of alpha if it hit the target. Another target at 23.1. Can it hit the target? And a third one at a distance of 10 meters. What's the height? Can the target just be hit? So we've got a few different situations, and we're going to try and use the equation of trajectory to solve each one separately. So we'll start with part one of the question. Okay, first thing I want to identify is what do I know? Well, I know the initial velocity was 15, so u is 15. I know it's going through the point 14.4, so x equals 14, and I know that y equals 4. If we substitute this into the equation of trajectory, we're going to get 4 equals 14 tan alpha minus 9.8 times 14 squared, 1 plus tan squared alpha, divided by 2 times 15 squared. Now, to make this easier for myself, what I do is I work out 9.8 times 14 squared over 2 times 15 squared and get that as a fraction. So this gives me 4 equals 14 tan alpha minus, I haven't done that on my calculator, 1920.8 divided by 450 times 1 plus tan squared alpha. Multiplying through by 450, that just makes it a little bit easier, gets rid of the fraction part of this one. That gives me 1800 is equal to 6300 tan alpha, take away 1920.8, take away 1920.8 tan squared alpha. Now it's a case of just rearranging it, bringing all the terms onto one side, so we get a quadratic equation in tan alpha. So 1920.8 tan squared alpha minus 6300 tan alpha plus 3720.8 equals nothing. Now, use my calculator to solve this one. We find that tan alpha is going to either equal 2.51 or 0.77, which gives me alpha as being 68.3 or 37.6. Now for part two of the question, we use a similar approach to start with. So this time we still know that u equals 15, but we've got x equals 23 and y equals 1. Now, if you set up the quadratic equation before, you go through the same process and you simplify it, you end up with a quadratic equation which reads as something like this: 5184.2 tan squared alpha minus 10,350 tan alpha plus 5,634.2 equals 0. Now, the interesting thing with this is, if you were to put this into your calculator, you'll find you'll get complex solutions to it. Or if we work out what b squared minus 4ac is, the discriminant, you're going to find that the discriminant is less than 0. So that implies there are no solutions. So in the context of this question, there is no angle alpha that would enable you to hit the target. We cannot hit the target. So for part three of the question, we need to apply the same logic again. So we know this time, again, we've got our u as before, u is still 15, and we know that x equals 10, but this time we don't know what the y value is going to be. So let's say the y is h for the height of the target. So setting up our equation just like we've done before in each of the other cases, we've got h this time equals, we're going to have 10 tan alpha 9.8 times 10 squared multiplied by 1 plus tan squared alpha divided by 2 times 15 squared. So rearranging this like we did before, it simplifies down to 98 tan squared alpha minus 450 tan alpha plus 98 plus 45h. Put that in a bracket because that's our constant term, equals nothing. Now, because we want this to just be so there's just a solution to it, we're going to use the discriminant. So b squared minus 4ac will equal nothing for just one repeated solution, one repeated root. Substituting my values into it, we're going to have 450 squared minus 4 times 98 multiplied by 98 plus 45h. We know that was going to equal 0. And solving this, we find that h is equal to 9.30 meters, 9 meters 30 centimeters.